Okay, so good evening. So we will start the recording. So before we start, I will like to request your permission to allow the recording for the lecture, and this would be in public on YouTube so that you have a copy because this is more on the subnetting. So we need to have this recorded because there are only few students who enter the class. So maybe it's important for you to solve because on Wednesday you will have a activity, so it would add up to your submissions, and this is likely uh, to be useful when I'm going to give a specific problem. But for the meantime, we will focus more on Class C subnetting because we are having only few hosts uh, to the network. So that is why it's important for us to have this lecture. So for Class C, so we have a maximum of 54 hosts, 254 hosts, and the number of host bits are 8-bit. So, okay, so we are already finished with lesson. We're all going to finish now, lesson 3, and what we're going to do. So at lesson 4, I'm going to discuss every application in a matter of maybe an hour, and this would help you finish your project. I will not give a big company that you're going to create a subnetting. So in the example, after there are a few slides, we're going to see how subnetting works and how it will going to be if you have background in IP addressing. So that's why we have a lot of topics on this side because not enough background will not give you much information how subnetting works. And if you know to identify network ID and host ID is also important in this subject, in this uh, next topic. So we now move forward to this slide. Okay. So if you're going to, what we mean by subnetting is it's like dividing each number of hosts into equivalent values. So this is the method that we have. What do you think usually we have in network ID? We have 8, 16, 32. What do you notice? Do you notice on the following numbers? We are having even number usually, right? And also the number of hosts. Please recall this. So this is important. So you need to use this later when identifying the number of hosts. And n is the number of bits. So later we will use this also formula. And as a recall, these are the Class A and Class B addresses and Class C. For our topic today, we will focus more on Class C address. And given a time, few weeks, so we will have Class A and Class B. But the easiest method that we're going to use is more on Class C. So this is applicable. In fact, this is used mostly in small offices and some business. So that's why Class C, you could create a private address using Class C on your own home or on your own business. Now, we move forward with this private address. So this is an example of your private address. So we discussed this already last time. And I think this one, just a reminder. So mostly we use a cidr notation. So this determines the number of bits in the subnet mask. Okay. So, and this is an example. Okay. So we have an example yesterday. So you could try to see the video last yesterday. So I discussed this already. So it means that when you have 24, so you have 255. So this is 8-bit, 8-bit, and 8-bit. So adding this up, we will have 24 CIDR, and these are the number of bits in subnet mask, leaving 8-bit for your host ID. So 0, so this is your host ID in class. Uh, this is not so 8-bit is 0 for this subnet mask. Okay. So for example, if I put here a 0, it means that how many would be your host ID? For example, I erase 255 and put 0 on your subnet mask because usually this is a class B. So the answer is, so if I put example, uh, then I erase this, I make it 0, and this is 255, 255 dot 255 dot 0 dot 0. So it means I'm going to leave you uh, 16-bit, but your notation will be different. So this becomes now, this is not going to be 24, but this becomes how much? So this becomes 16. Okay. If I'm going to implement, for example, class B. But in this example, we are just having to identify the notation. And given the subnet mask is for class C, so leaving it will you have 8-bit for the host ID. Now, for this, so I am going to you have this example, and you're going first to convert to 40 into binary to determine how much would be the network ID. So why is it we have 20 bits? Again, so we convert this. This is becomes 8-bit, 8-bit, and what we have here is uh, we have four ones. Okay, so meaning a subnet mask will always determine the network ID if you see ones. Host ID will determine if you have number of zeros. Take note of that. So if you count the number of ones here, one, 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 one. So you will have four you have apat na 1 and you have 0. So if you count it, you will have 20. So that's how you get your cidr notation by counting the number of network ID or the number of ones in binary. So you do not focus on your IP address, but you focus your cidr notation on your subnet mask. And after that, you determine your network ID on the subnet mask. So you're going to put 20. Okay. And broadcast domain, I think we will use this later. We have your broadcast address. It defines which devices must receive a packet that broadcast by another device, and each port on the router constitute a broadcast domain because routers don't forward broadcast packets. Only TCP/IP communication relies heavily on broadcast packet to perform a variety of function. Okay, and this is a part of your also test also, and this one. So we will now go to our topic on subnetting. Now, for example, our lesson proper on subnetting, for example, if you have this number, uh, 172.31.0.0 slash 24. So, and you have this another example. So up to 255. So this addressing strategy is subnetting. It makes 256 smaller subnets with a maximum of 254. So these are the number of devices per subnet. Okay. So these are the maximum number of subnets that we will have. And to understand why subnetting, if a computer on one subnet needs to communicate with a computer on another subnet, the packets are sent to a router that locates the subnet and forwards the data. Now, the maximum size of your broadcast domain is only 254 computers, which is more manageable. That's why in Class C, we are only having 254 hosts that we could use. So this is basically used for local area network. And another reason why we need to subnet is to conserve IP addresses. So company that maintain internet connected devices need public internet addresses, which must be unique in the world. So meaning a public address can be assigned to only one device on the internet. So you have a unique address. So if we create a private IP address, so we could still reuse the address, but you could not uh, apply it when you're going outside because you will have another address outside the network. So that's how we conserve IP address using subnetting. And also, the third reason is to subnet is to divide a network into logical groups. So when one large network is divided into two or more smaller subnets, a router is needed to allow hosts on one subnet to communicate with hosts on another subnet. For example, later, this is an example what we have. So I have subnet 4. So this one will comprise another department. This also will comprise to another office. And this also comprises to another office under Ferrari. And this also comprises to another office in Ferrari. So both car manufacturer communicate using a wireless link. So this is an example of a fast Ethernet logical arrangement. So it depends on what application that you will consider. Now, as a summary, so subnetting will manage our network. Second, to conserve IP address. And third, to divide the network into logical groups. So that's why we subnet. Now, how do we calculate a subnet mask? So earlier, we already know to determine the network ID and host ID on different types of classes of IP address. So it's going to depend on the following questions. So why we need to subnet? So what are the requirement that we need? For example, we need 60 computers. So it depends on what computer, or it depends on the number of the computer that you will going to connect. So, or I am subnetting to provide network with a certain number of subnets. So this is like you're going to group the IP address into subnets. And inside the subnet, you have different computers that are connected. So if you're working for an ISP, the answer is usually yes to the first question. So this is applicable, for example, if you are hosting a network at home. So you could manually uh, adjust your network on how many people is going to connect to your internet. And if you are a network administrator for a on an organization, so the second question is applicable because you will provide large network of devices. So combining them is also a good reason why we are going to subnet. So these approaches are relevant in our subnetting paradigms. So the next step is to calculate subnets. First, we need to decide how many subnets you need. So you can figure out by the number of subnets by seeing how many network cable segments or will be connected to the router interfaces. So each router have a connection indicates the required subnets. So this is more on the application on the physical or on the laboratory. Next is we decide how many bits you need to meet or exceed the number of required subnets. To calculate the value, you usually use the formula 2 to the n, and with n representing the number of bits that you must reallocate from the host ID to the network ID. So you are going to now we know already last few days we know already what is the host ID and what is the network ID. Now, for example, if you have class B network that has a starting address of 172.20.0.0, the default subnet in class B is 255.255.0.0, which is always your starting point. The number of subnets you create will always have a power of 2. So that's why we always have an even number on our number of hosts because we are always at the power of 2. So if you have, example, 20 subnets, so you must reallocate 5 bits of uh, 5 bits in the host, and if you are allocating for 4 bits, so you give only 2 to the 4, or you have 16 subnets. So meaning how many subnets you have? You have 16. So the more subnet you have, the more division you create. So for example, if you have a 16 department in CAMSI Talisay, so you are going to allocate for 16 division. So this is from another college, this one from canteen, this one is from. So making this would allow you to uh, properly manage each subnet. So why we're going to reallocate bit so that you will have different ID for each department, so not colliding with another department. So in this way, you could make local area network with the host ID. We will starting from the most significant host bit, that is from the left side of the host ID. So where's the left side of the host ID? For example, where's the, okay, I will just move forward. Example, where's the most significant host ID? So this is the host ID that we have, okay? So the most significant part is on this side, on the left. Okay, so next, you must also make sure that you have the host bit available to assign to computers on each subnet to determine the number of host addresses available. So we use the formula 2 to the n minus 2, that is representing the number of hosts or 0 bits in the subnet mask. Okay. Now, given this example, so we have class C. So before we start this, are you still following? Anybody?
Yes,
Yes,
sir.
sir.
Yes,
Okay.
sir. Yes.
Also, this is not included in your notes. So please get a paper and write something about this one, because this is just uh, more detailed explanation on how to calculate, because on this side you could not really understand how, but on this side it's going to be step by step. Now, for example, given this IP address, normally this is class C, and this is the default subnet mask for class C. And if you convert it into binary, you will have this below. Now, example, let's say we're going to consider uh, 2 bits that we're going to take from, we consider 2 bits to be taken from your host ID. And why we're going to take 2 bits of information to host ID? Because, for example, we're going to manage 4 subnets. And usually, this question is already on the statement. Example, in the problem, in a coffee shop, there is uh, a lobby that you need to create a network. And also, we have first floor and second floor. So you have another connection on the first floor and the second floor. You have the office, and you have the spare connection in cases there are guests and VIP. So, for example, you have first floor, uh, second floor, and you have the office, and you have the spare connection in cases there will be some activities that you require more hosts, and you have a spare. So let's say you have a coffee shop and you have to require four subnets. So we take example on this IP address. We are using this IP address and this subnet mask. So we will have, let's say, uh, the connection. So, so if we require four offices, so we use four subnets. Now, since we're going to calculate for how do we get four subnets, so we start from your left side. So this one becomes one, and this becomes one. Okay, such as this one. Now, how do we formulate your new subnet for this example? So we count from 1, 2, 3, 8 plus 8 plus 8, and this becomes 24-bit, and you have 26. So this is your new CIDR notation. Okay, this is your new CDR notation. What about on the first? So on the first, this one is only how much? This is only 24, right? Now, since we're going to compute for four subnets, so we will have the new subnet now that is on the maximum of this 26. Now, on each subnet, there will be also different subnet on each. So for this example, this is the new subnet. Okay. Now, let's say how many hosts per subnet we have. So where do we count? Where do we get six? Anybody? Where do we get six? Take note. Host is your.
The zero, sir.
So this is your host. Okay. The number of zeros always will be your host. Number of zeros, and the number of ones will be your network ID. Okay. So you always count how many subnets from your left most significant bit before this was zero. Okay, given that we have this problem that you're going to create four subnets in a coffee shop, so this would be the result. Now on each host, so you will have 2 to the 6, that is 64. Okay, so in each host, on each subnet, you will have 64 hosts on each subnet. And the range would be from 0 to 63. And also, that would be later. I will move to the next slide. The result will be different. So on the next slide, you have this one. So your range from this number. So that would be the range of your IP address. So so 0 to 127. This is only for one subnet, okay? And I already put the second subnet. But in cases, how many subnets we have to consider on this example? Sorry, this is so this one. So this should be 64, okay? So 64, and you have also this. This is 1 to 8. and it's going to 191, and the last part would be 1922 uh 254. Okay. So that's the subnet range. So that's how we divide each uh, subnet because the maximum number that we will have is 255, but since why we lack why only 254? Because on the formula, take note, we subtract 2, and since 2 will be considered as for your subnet number, your first subnet number, likewise that is 0, and you have your broadcast address. So that's why we lack we need these two in order for us to send the information. So we have unassigned a subnet. So that's why we subtract 2, that is for the subnet number and for your broadcast address. Now, we have these subnets being produced, and also we could also produce 4 from our maximum subnets. So on the next slide, this would be the result for the next slide. So this is example subnet 1. You have 192.168.1.0. This is for the first subnet. For the second subnet, you have this. And example, if we have our subnet 3, this one, so that would be based on 64, 128, and 192. And the maximum subnet you will have is broadcast address is 255, but your valid host will be until 254 only. Okay? So take note, every subnet mask is reserved. So once you use this already, you could not use this in the addressing, but it would be a part of your subnet mask. So this one also is reserved, so you could not use this IP address. This is for the broadcast. At the same time, this one. Okay. So the usable host that we could have is this one. These are the usable hosts that we could use. And also this one and this one. So any question? It's difficult or not? The equation that we'll have is only this one. Okay, I will erase it. Ang equation na gamiton is only this is the procedure. Okay, so this is the procedure that you will have. Okay, so subnet mask is you will have this example. One assignment that I have for you is this one. So class B. So for class B, you have a different subnet mask. So that would be different also. And this one is class C. So how many hosts are in class B? How many hosts are in class B? There are about 65, or how many? Take note, class B, you have a maximum of six
54.
65,534 devices that you could connect. But in our example, in class C, you will have only 254. Okay? So any questions on class C? If you don't understand this, I will repeat it again. This example. For class B, you focus on the third octet and the fourth because this one is class C, so this considers only this subnet mask. Because this class C mostly it's like real in class C we are focusing more on small network computer network and class B is more on medium sized company. Maybe this class C is for small medium enterprises. Any question on this example? Shall I repeat it again? Or it's okay? We will end our lecture on this side and make sure that you could submit your assignment 6. Okay? Any more questions?
None, sir.
Okay, none. Okay, let's say I will have another example. Okay, so what if I'm going to have based on class C? Uh-huh. This. Uh, what if I'm going to divide the network? I will just only have one coffee shop and one park. And I will not have office IP address, just a public IT that is in example 200 people in Bacolod park is so example I have to divide each by one 128 bit. Let's say we have one. So I only divide the network by so this okay okay. So I have we change this one into this. So what will be the new subnet? So this one is how much? This is only 1000. This is becomes 1. This becomes 128, right? Because ging 0 taang 1. Now, how many subnets do we have since we only have 128 values, 128 bit? How,
25, sir.
how many subnets? So your CIDR notation is 25. This becomes 25. And your how many subnet do we have? How many subnet? Where do we count this? So din gani dire, di ba? So this one, 1, 0. So we start from the left. So where's your left? So this is your first subnet. your fourth octet. So this is your first left, 1. So we have 1. So how many subnets we will have? This is wrong. 2 to the first. What's the result?
So, sir,
So 2. So we have 2 subnet. Okay? We have 2 subnets. Now, since we have 2 subnet, so meaning 128 minus 256, so you have 250 plus each, di ba? So maybe you will have 25 253, yes, 253 and 253. So you have two subnet. Now, where do we get the number of n?
So zeros, sir.
Number of zeros. So this one is your number of zeros. So how many are the zeros here? You have
Seven.
7,
7.
sir.
seven. So seven, you will have 7. So 2 to the 7 is how
One
many?
to eight.
So you
8.
have 1 to 8 hosts per, you have 1 to 8 hosts per subnet. So meaning your subnet range would be different. So your subnet range will become here 0 to 1 to 7. Why? Because we count 0 as your first number. So that's your subnet range. And your subnet for this example, this one would be correct. This is your first subnet. Your second subnet, maybe we will have it by 1 to 8. And you have only these two are your subnets. Likewise, in the previous example, we have 4 subnets. And now we have how many are the valid hosts? So again, you will use this 2 to the n, 2 to the 7 minus 2. So what is the result? How many hosts do we have? So this is
126.
what's the value? 128 minus 2, that is you have 126. So you will have 126 each. Okay? So you start your count from one from 0 to this point because why 126? Because 1 to 7 again will become your broadcast address, and the other will be your subnet number. So without having to consider subnet number and broadcast address, you could not send the data because you will not have. It's like having the letter. You have the receiver and the sender. So kung wala ka duwa na sending and receiver, you could not send the letter. So that's the same also when you have this value, this equation or this formula is important. The two symbolize again your subnet number. What is your subnet number for this example? So you have two subnet numbers. So this one and this one is your subnet number, and each subnet number have its own broadcast address. So you have your broadcast address. So in that case, actually you use 4 bit because if you start your count from 0 to 1 to 8, ang ginagamit mo lang da is until 126. So meaning the four are being used as subnet and broadcast. So I mean, ginagamit mo is 1 to 26. So because the other are used for broadcast and subnet. Now, I think this is it clear already? So I have a second example. I think that's way easier. So we'll erase this and I will have this lecture on also on YouTube so that if you were absent, you could still catch up. And please, if you want to retake the test, if you are not feeling good at your score, so you could take once. And also, I have already have the previous students who have retake the test. So, any more questions? Because we end our lecture 3 in subnetting actually on this example, and we move forward. As a recall, so that you could practice subnetting, you try to answer uh, this one. So this is also a good example. So there's also a tip on how you're going to allocate 6-bit. Now, in this example, we allocate how many bits? We allocate 4-bit on class C. So that's why we have 4 subnet. So in this side, we allocate 2 bits, but each bit is considered, you allocate 2 bits for having 4 subnets. So take note on every, on this side, so the maximum value you will have is, you have a 64 range in every subnet. So that's how you divide each that's how useful subnetting is in IT. So you could divide each connection into different number of hosts. But in your project, I will not have 64 addresses because on your Cisco packet tracer, you will also have 64 computer, right? If I allow you to design this address, so you will have also 64 computer on each department. So it's not maybe it's a good practice, but I will have only maybe few number of devices to be connected because we move forward with the VLSM. It's a totally different network. Okay. So any questions on the calculation? It's an easy calculation, but you need to understand that there will always be two addresses that are not assigned. So you need to adjust also your broadcast address and make sure that you're not going to use 63 because once you use 63, your valid host, as you see, dito, dere wala 63 because we reserved 63 as broadcast. And also, and other example, we also reserve those numbers. But the range, so they are included in the range, but on the calculation, they are not included. Okay. So I think we have some questions. Any questions from our uh, example? So I always ask this in your test, mostly. What are the subnet masks? What are the range? What are the valid hosts? So to calculate, you always remember this equation and this. And sometimes this one is given to the question. This one is implied, meaning like this example. So I will just say I need four subnets, or I need the four department to connect to a different subnet. So that is the implied question, meaning you need to show this also, and to show your calculation. And also, okay, so we move forward to uh, this is an example of the subnet mask. So these are the subnetwork addresses in your notes. And okay, we have the bit reallocation, usually on the third octet for class B. For class C, you focus more on the fourth octet. Now, this is an example of class B also, discussing how it was calculated, and another assignment for case 2. So this one. So given the following, calculate the network for this. So we have, for example, 40 Windows host, and this one 60. What you need to do is just to allocate, since you could not use all of the IP address, what you're going to do is you try to make uh, the host available for each network. So how many subnet do you have here on this assignment? How many subnet you have on the diagram? Pila. On the diagram, how many subnet did you see? Anybody here?
Four, sir.
Subnet. You have subnet
Two, sir.
A, subnet A, subnet B, subnet
Four.
D, and subnet C. So you have four. Okay. So it's similar to my computation. So what you're going to do is just to assign IP address. And how to assign IP address? So meaning, if you have from this address to this address, you will have this. You need to, from 0 to, you count the number of the address not exceeding the value. So not exceeding the value of 100, this one. So you allocate the number So this one you have 100 Windows computer and 10 hosts. So this is 60, 50, this is 40, and example 60, this is already 50, 60, 50, 1. This is included, so this is 52, 52, and this one is included, so 53, and this one. Take note, you need also IP address for your switch or router because how can you communicate to router if the router doesn't have an IP address, right? So you need also to put IP address on your router. Okay, so I think this one is going to be easier. So this IP address. So you have 62 is 42, and you have this one. So you add up and you have already. So similar to this case, to my example, you have a also possibly I will re-upload the notes. I-upload ko ni Liwat so that you'll have a copy. And that's it for this period. Hoping you could finish your exercises. So this is a summary of identifying your CDR notation. So as you notice, the maximum CDR notation you have would be until 32 in class C. This is class B, and this is class A, class B, and class C. So these are the summary. So you could use this in your assignment 6 and as well as 7 for this is for assignment 6 and this is for assignment 7. So you could use this summary. And what we have here is like your assignment 6. It's actually discussing what you're going to do. And what you're just going to present is the number of hosts, the network ID, and other elements. Okay, as a summary for our lecture 3. So it's good that we end already our lecture 3 because it's been several weeks that we are having this background and review of your previous network 1. So IP version 4 is a 32-bit dotted decimal number separated into 4 octets. So every IP address must have a subnet mask to indicate which part of the IP address is the network ID and which part is the host ID. And we also able to determine on the each using test 03. And for your second, there are 3 main address classes used in computer network. These are class A, class B, and class C. So the address classes determine the default network ID and host ID portions of an IP address. So each class has a range of private IP address that can be used on the internet. So they are basically used for private network. In fact, cidr largely replaces IP addresses class system. It uses a prefix number or subnet mask to determine the network and host IDs of the IP address. Subnetting enables the administrator to divide large network into smaller networks that require a router for communication. It also allows an ISP to allocate only the number of IP addresses, and the company requires instead of assigning an entire address class. thereby conserving IP addresses. Subnetting also allows dividing networks into logical groups for security and efficiency. The last summary is there are several rules for IP address assignment. Only Class A, Class B, and Class C addresses can be assigned to a host. So every IP address must have a subnet mask, and all host IDs on the same network must be unique. You can't assign the network number or broadcast address to a host, and computers with different network ID can only communicate through a router, and the default gateway must have the same as the network ID as the host. So I think that's it. And we end our lecture 3 on this day. And tomorrow we'll have a short. We will not have a class tomorrow, but I will give you assignment and another test on subnet mask at the same time on network ID. So any questions? Any questions?
Okay na, sir.
None, sir.
Okay.
None, sir.
Okay, thank you for attending the class, and I'll stop the recording. Thank you and goodbye.
Thank
Thank
you.
you,
Good.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Yes,
sir.
sir.